All right, this is lesson 0.2, combined like terms and the distributive property for integrated math 1. Our Khan Academy skills are right here. So this is Khan Academy, math 1, algebra foundations, skills 4 through 7. We have two objectives in this lesson. Our first one is that students will be able to combine like terms with integers and rational numbers. So the key here is that you need to be combining like terms. I'll explain what that is in a moment. But you'll be working with integers and rational numbers. So recall for a moment, an integer is things like 0, 1, 2, and so on. It's also negative numbers like -1 or -2 or -3 or whatever. It's just not anything in between. It can't be something between 0 and 1 or something between 1 and 2. Now, rational numbers, you should recall that a rational number, it's based on the word ratio, which means fraction, right? So rational numbers are numbers that can be expressed as a fraction of integers. So things like 1/2, 1 and 2 are integers. 5/2, it's improper, but it's still a fraction, right? And 5 and 2 are integers. Even decimals, as long as decimals stop, so like if you had 0.75, that decimal stops. There's no digits after the 5. So it is rational. And if you don't believe me, check in your calculator what 3/4 is. 3 divided by 4 is 0.75. 3 and 4 are integers. This isn't a fraction of integers, so it is also a rational number. And then this is a little bit of a bunny trail, but any decimal that has a repeating pattern is also rational. So we'll need to combine like terms with integers as well as rational expressions. Okay, and then our second objective here is pretty similar. It's about combining like terms, but you should be able to use the distributive property to solve and combine like terms. So this distributive property here, recall from earlier math classes, that's the distributive property of multiplication over addition. So an example of the distributive property might be something like, excuse me, let's say you had 2 times 4x plus 7. We can distribute this multiplication, this multiplying by 2, over addition. In fact, let me color code this for you. So 2 times 4x, that should be 8x. And 2 times 7 is 14. So 2 times this quantity in parentheses, 2 times the quantity 4x plus 7, that is equivalent to 8x plus 14, and that is the distributive property. A lot of times in earlier math classes, if you remember your math classes maybe from elementary school, you might have also seen like the box method of multiplication. So the distributive property is also applicable to things like if you wanted to do 25 times, 7, you could call that 20 plus 5 times 7, and you could do 7 times 20 is 140, and 7 times 5 is 35, and then you add those up, right? That's also the distributive property too. It might not seem very important now, but in future math classes, you might go back to that box method someday. So don't forget it. Anyway, I'm throwing around words like terms or like terms, and in math, the word term is a very specific thing. So let's go over the definition of what a term is in math. So a term is part of an expression. Remember, an expression from last lesson, that was a vocabulary word. It's something in math that doesn't have an equal sign, right? So an expression can have numbers and variables, addition, subtraction, multiplication, division, but no equal sign, right? And in an expression, there are parts called terms. Terms can have a coefficient and a variable or variables, and terms are going to be separated. They're going to be coefficients and variables that are joined by multiplication. Sorry about that. So for example, 2x is a term because it has a coefficient, 2, or a number, and it has a variable, x, and that 2 and x are joined by multiplication. 2x is a term, 3x is a term. You should also know that the terms in an expression are separated by addition and subtraction. So this subtraction symbol here splits the terms up. So 2x is a term, but 2x minus 5 is not a term. They're two different terms. 2x is a term, minus 5 is a term, and that addition separates terms too. So 3x is a third term. And I actually answered our first question in our example by saying that, but that's okay. So we have an example here. This expression, I'm asking you how many terms are in the expression and what are they? We just said there's 3 terms, 2x, minus 5, and 3x. Let's see. Let's go ahead and, I have a red definition here for you, but before we get to that, let's go over the blue stuff here. So how many terms are in this expression and what are they? Take a moment, pause the video if you need. How many terms are in that green expression there? There are 4 terms, 3x, minus 2, minus 5x, and 6. One thing that's really important, go ahead and add this to your notes. We saw it up here, we saw it down here as well. It's important that the sign in front of the term it stays with the term, it's attached to the term. This is important because that means this 2 is not just a 2, it's a negative 2, because we'll be adding later, and adding 2 is a lot different than adding negative 2, right? Okay. There we go. All right. Let's go ahead and go to the red definition. So I'm going to zoom in a little bit for you. Like terms are terms with exactly the same variable, or if there's more than one variable, they have to have all the same variables. To combine like terms, we add or subtract the coefficients. So as a quick example, let's say we had 3x plus 5xy plus 7x. Now this term has 2 different variables in it, right? It's not a like term with the other 2. However, 3x and 7x, those are like terms because they have exactly the same variable, x. And to combine like terms, we add or subtract the coefficients. So 3x plus 7x, that's 10x. And that 5xy just has to stay there. It doesn't combine with anything because it's not a like term with anything. Okay, let's try to before we do that, in the 2 first examples, that should say are there any like terms in that blue expression? If so, what are they? Hopefully you can recognize that 2x and 5, and that should say 3x. My mistake. 2x and 3x. There we go. 2x and 3x are like terms. In the green example, are there any like terms? If so, what are they? Take a moment, pause it if you need. Hopefully you saw that these two terms have x in them. So 3x and minus 5x are like terms. But also, minus 2 and plus 6, they both have no variable. They're what we call constant terms because they don't vary, they don't have a variable, they don't change. So negative 2 and 6 are also like terms. Now that you can identify like terms, let's go ahead and combine them like we did over here in the red example on our page. So we have this big expression with 6 terms in it. I went ahead and identified the like terms for us already. So 5c and minus 8c, those both have the same exact variable, c. So we can combine them by subtracting their coefficients, their 5 and minus 8. So if we subtract 5c minus 8c, we should get negative 3c. And this is why it's so important that that minus sign stays with the term, because if you accidentally think that's just 8c and you put a plus, you'll get the wrong answer. 5 plus 8, what is that, 13? That's not the same as negative 3c, right? And same thing here. So we have two terms with the exact same variable f, 12f plus 3f, that's 15f. And then we have two terms that are constant, they have no variable, so we can combine them. Negative 30 plus 7 is negative 23. Now, all of this stuff here is just kind of scratch work showing how we're combining our like terms. But when I give you a problem, I ask you to combine your like terms, you can put this stuff down to show your work, but this is what I'm going to be looking for. So you should be able to do some mental math as you gain more practice with this stuff. You can go ahead and just say 5c minus 8c and put that combined term there. And if you can take this 6-term expression, combine your like terms down to a 3-term expression, then you are meeting that objective of combining like terms with integers. We didn't do rationals yet because 5, 12, 38, those are all integers. But if I changed 5 to, a half or something, then you would be meeting the objective with rational numbers, right? So we'll see that a little bit later. Let me go ahead and zoom in. We have 4 examples here. Go ahead and try them on your own, and then pause the video, and when you're finished, come back and check your work. All right, so our first example, we have 2 like terms that have the variable r in them. We can combine them. So 5r plus 12r, we should get 17r. And then we have 2 constant terms, negative 8 minus 20 is negative 28. I do want to put a note here that if you did it in a different order, maybe you did the constants first and got negative 28, and then you combined the terms with r in them and got plus 17r, that's okay too. However, you should know that the general convention that we use in math is we usually put the variable first and the constants later. So the constant usually goes at the end. All right. Here's the second example. This is meeting that rational number part of our objective because these are decimals that stop. These are rational numbers, not integers. Okay, so again, like I mentioned before, we're going to combine our terms with variables in them first. Negative 1.9t plus 5.1t is 3.2t. And combine our constants, we should get minus 2.4. And we've combined our like terms. That's our answer. All right, in this one, we've got more than one variable now. So to add on to our general convention in math where you put the variable terms first and the constant terms Next, if you have more than one variable, you usually put the variables in alphabetical order. X comes before y, so let's combine those x terms first. We should get 14x. If we combine our y terms, negative 12y plus 8y is negative 4y, and then we can save our constant for the end. There's only one constant, so there's no combining going on for the constant term. It just needs to stay in our answer. And that would be our answer, 14x minus 4y plus 4. Our last example, let me zoom out a little bit because there's a note I want you to add to your paper. That's right here in purple. When variables have exponents, the exponents must match in order to be like terms. So don't make the mistake of saying that, oh, well, 5s has an s in it, and negative 6s squared has an s in it. So they're not like terms, because 5s only has one factor of s, while negative 6s squared has two factors of s. They are not like terms. But if the exponents match, like these two do, then they're like terms. And adding on to that general convention for math, where you put the variable terms first, if there's more than one variable, you put it in alphabetical order, and you also want to put the highest exponent first. So the highest exponent attached to an s that I see is a 2. So we'll do those first. Negative 6s squared minus 3s squared is negative 9s squared. Then we'll do the s term. 5s plus s is 6s, and that constant still stays there. We're going to save this one for in class. I want you to try it on your own. Make an attempt down here on your page, and we'll go over it. We'll talk about it in class. I will give you a hint, though. If you're stuck, look at the table from lesson 0.1. The one that talks about what symbol could sum mean, or what does twice mean, stuff like that. And I think that's about it. Oh, I just noticed, though, we did not have an example that covers this objective, just the distributive property. It's not that much, so let me just pick a problem from your practice problems that shows an example of the distributive property. Here we go. These ones will do it. So this first one here, we're just going to distribute and then do everything I just showed you already. So we'll distribute first. Because we have these parentheses here, let's distribute. So we have a plus 8. We'll distribute that over the parentheses. So this is negative r, and then 8 times minus 5r is minus 40r, and 8 times minus 2 is minus 16. And then we do what we just did on the last page. We need to combine our like terms. So in this case, minus r and minus 40r, those are our like terms. So that's negative 41r, and the 16 doesn't combine with anything. So that's our answer, which is right here. When you're distributing, make sure you keep that sign attached to the number next to it. I'll do one more example here because this minus sign kind of changes things. If there's nothing in front of it, go ahead and put a 1. That's negative 1, and then we're still going to distribute it to the stuff in the parentheses. So this would be, well, the negative k will still stay there. And then negative 1 times negative 8k. A negative times a negative is a positive, so that should be plus 8k. And then negative 1 times positive 7, that should be negative 7. And then if we combine our like terms, negative k plus 8k, that should be 7k minus 7. There we go. And that is lesson 0.2. As always, reach out to me if you have any questions, and I will see you in class.